Now let's take a look at reading data from a file. If we have very much data to deal with, then we don't want to be typing it in from the keyboard. It becomes very cumbersome and really unrealistic to be able to process data if we have to type it in all the time. So typically, if we have anything of any consequence, any size, we want to read that in from an existing file. Or in many cases, we want to write the output from our programs to a file instead of just writing it out to the screen where it disappears as soon as the program ends. Now, let's begin by reading data from a file. What do I mean by file? Well, I'm going to bring over on my Windows machine, I want to show you some files that I have. So under my temp folder on my C drive, and I'll just navigate to that for you. So if I double click on the C drive, then we can get to what we call a folder. So in the temp folder, I have some files. So a file definition is just a collection of information in digital form. So you'll see quite a few things here. All of these have a .txt extension, which means that these are what we call text files. And if I double click, then I can open them up. And if I move this over, then you can see that this is readable. So we can read this sequence of bases, and notice that the cursor is blinking right below. Now, let's look at some other files. This one's really very simple. Let's open up a different one. Here's one that has quite a bit of information. So if I double click on it, then this is a text file also, but it has quite a larger amount of information here. So there's a lot of text in this file. I can also open up a file that has some temperature data. So let's open up this one, temps.txt. So if I open that one up, then this file is pretty simple. It contains multiple lines, but it has only one data item per line, and these numbers could represent temperatures. All right, so all of these files are files that we can read if we open them up with a tool like our Notepad or WordPad or whatever you're using on your computer system. Other files, and the vast majority of files are going to fall in this category. Those are not going to be text files. If I try to open up this one, this is a JPEG, so this is an image, but if I try to open it up, then it's going to want to open up with something that can read an image. So if I just double clicked on it, it would bring up Paint or some program that would be able to deal with images. But if I want to try to open it and read it as a text file, then I could try to do an open with, and if I try to open it with Notepad, then we can't decipher it. It's unreadable. So we have a bunch of weird characters. So whenever you open up what we call a binary file, this is typically what you will get if you're trying to read it as a text file. It just doesn't work. So things that are images, a lot of things like songs, video, all those types of files, those are just going to be binary files, and we'd have to have special tools in order to look at them. So we're not going to be dealing with those. We'll be just dealing with text files. So let's close this. And I want to point out one more time that this dna.txt file is the one that I'm going to be working with in this example. So if you don't have that file, you ought to just go ahead and create it. So just open up your text editor and just type in those bases and save that as a file, because we'll be using it in the upcoming example. Now then, how do we open and use those files? This says we want to read data from an existing file. With Python, turns out it's pretty easy to do that. So we need to do several things, but all of them are simple. The first thing we need to do is we need to make sure that we know the name of the file. So the name of the file I've just told you is dna.txt. So let's just keep the name of the file in a variable. So let's do my file name. So that's with underscore. So that's a variable. And that's going to equal to double quote dna.txt, close double quote. Okay, so that's the name of the file. And we'll come back shortly and we can put in the complete path here And if you want to just use the name of the file without putting the complete path, then there's something special you have to do with that file, and I'll show that shortly. But for the time being, we're just going to set the name of the file. Now, we want to open the file. Okay, so we're going to do an open file command. And in order to open the file, we need something that we call a file handle. It's something that allows us to connect our program to the file wherever it may exist. It may be on the C drive, it might be on a flash drive, it might be somewhere else, but we have to connect our program to that file, and this is how we do it. So I'm going to call it a file handle. Okay, so a file handle is equal to, and we use the open function. Okay, so we use open, and then in parentheses, we want to give it the name of the file. Then here we can either use this string constant, or we can use the file name. Okay, so I'm just going to use the file name since I've gone to the trouble of making it. So I'll paste that in here, and then I'll close that with the right parentheses. Okay, so that connects our program to the file. So let's put a comment here. Okay, we're going to connect our program to the file. So this is all going on internally. So whatever magic has to happen in the computer to connect this program to the file that is located on disk somewhere, then this is what happens. So this is what's needed. So we put this in our code, and we let the operating system take care of actually doing the connections internally. Now, once we have done this connection, we've opened the file, then the way that we get to the file is using this file handle. Now, let's suppose we want to get the entire file and we want to read it into our program. I'm going to make another variable, my file contents. Contents. Okay, so my file contents is going to equal to the file handle. Okay, file handle, and then we're going to use a method, file handle dot read with empty parentheses. All right, now that will read in the entire file into our program. Okay, the entire file, the whole thing. Okay, so we're going to read in the entire file, and now it will be saved in this variable, my file contents. Given that, we can go ahead and output that file to the screen and see what it looks like. Okay, so we're going to output the file to the screen. So we can do that with just our usual print command. So print, and this variable, my file contents, contains everything that's in the file. So we'll print that out. And also, let's get the length. Let's find out how long it is. So let's do print as well here. Print, okay, double quote, the length of the file is, okay, let's put a colon there, space, double quote. Then we will use the length function for that, but we have to embed several things here. It has to be converted to a string, we know that. And when we get the length of the file, we know that's going to be an integer. The way we get the length is string. Okay, we will convert it to a string. I'll get there. Okay, so we want to get the length, and that's the len function, and the file is called, the string is called my file contents. Okay, now I need to have an underscore there instead of a dash. Now let's close that. So that parentheses closes the len function. Okay, that closes the str function. I need one more to close the print. So make sure you have included all of the right parentheses that you need for this. So just a quick review, we want to get the length. So we call the len function and we give it this variable, my file contents, which contains the whole file. So that tells us how many characters it has. Then that's going to be an integer. Length is an integer, and we can't print out an integer and a string constant without converting the integer to a string. So that's what the str function does. So we've got like three things on top of each other here. We got the length, we got the str, and then we got the print statement. Now, this will print the file contents and the length to the screen. So let's take this and save it, and then we'll run the program. Now, I want to show you something that's important here. Okay, I'm going to save this program. Okay, I'm going to save as, and I want to put it in a special place. Okay, so I have a folder on my desktop which I'm calling CS100 Python Chapter 3. So I've already saved a version of my program in here, but I'm going to save it again since I've updated it. And it says, do you want to update it? Yes. So now I have saved my program in a particular place. All right. Now, in order to run this program, this file, this dna.txt, it also has to be in the same location as my program for this to work, because I didn't give it a full path over here. So let me go check to see if I've really got that stored in the same place. I'll bring up my file browser, and I'll navigate over to my folder, Chapter 3. And when I look in there, I see that, yes, I've got a file called dna.txt, and it's in the same place as my Python program. All right, so everything should work. So I'm going to run the program, and let's see what the output looks like. Okay, so we'll bring this over here, and you can see the output. So here's the file, and we see the list of bases across here, and you can compare that to the file, and you'll see that it is the same. And this says the length of the file is 19. Now let's count across, and let's see if we agree with that. Okay, so starting on the left, I'm going to use the arrow key. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. So I only count 18 characters, but it gives me a length of 19. Why is that? Alrighty, well, we can't see it, but there's an end-of-line character that shows up after the C in our file. We can go back and we can look at that. Let's bring up our file again. So let's see if we can get the folder up here. Okay, so let's navigate back to where I was. Okay, so desktop, Python, Chapter 3. Here's the DNA file. So if I open that up, then if you look carefully, then we have the cursor blinking below this first line. Okay, so there's the line of bases, and the cursor is blinking right below it. So that means that when I type this, I had an end-of-line character right here after the C. I hit the Enter command. So there's an end of line there. So that's the 19th character. That's where we get the length 19. So it's called an unprintable character. You don't print a \n, you actually go to a new line. So that's what we are doing here. All right, so that's why we get a value of 19 for this. Now, we will address that shortly, but before I go any further, I want to show you a couple of things that you can do with the files. Now, with my file name, I have a version of that that's stored on the C drive. So if you're running a Mac or something else, then the path is going to be different in your case. But I can put the full path in here. So C drive /temp/dna.txt. All right, so if you want to, then you can place your data in a different location than your program. And when you try to open it, you'll just need to put the complete and total path to where you have stored the data. So this works just fine. So that's because I've also stored a copy of the dna.txt. I have a copy of that file on the C drive in the temp folder, and I've got a copy of it in the same folder as my program, which you just saw. Now, with that small change, let's make sure that that does work. So I'll run the program, and we get exactly the same results. But this time, I'm pulling the file out of the temp folder on the C drive instead of the folder where I stored the program. So let's close that. The other thing that you can do is, if you don't want to use a variable here, then that's okay. If you know the name of your if you know the name of your file, then you don't have to go through the extra step of copying it into a local variable like my file name. So I can take this and I'll just copy it from here and I'll paste it in the open statement. Okay, so you can eliminate that step if you want to by just putting the name of the file inside the open statement as I've shown you here. Okay, so let's just take this my file name out altogether, and we will open the file by putting the name of the file here. Okay, now we should verify that that works. So I'm going to hit the F5 key, OK. And now you see that we do get exactly the same thing. So that's another way that you can open up a file. All right, now let's see what we need to do if, for example, we type a file that doesn't exist. You know, what's going to go on in that case? What happens if you get an error? Okay, well, let's put in an error. Let's suppose that I mistype the name of this file. Okay, so let me back up. All right, so now I'm calling this da.txt, so there is no file called da.txt, so I'm going to get an error in that case. When I run the program, then we will get an error message because it can't open the file. So here we have the error message. So you can see that there's no such file or directory, and it tells you here is what it's trying to find, but it didn't find it. So this error message is pretty clear. That indicates that you had a typo, or maybe you didn't store your file where you thought you did. At any rate, if it cannot find the file, then it gives you this error message. So let's close that. Now, the last thing that we need to do here to make our program complete is to close the file. So we didn't do much with this. We just opened the file, and then we printed it to the screen, and then that's all we did. We did determine the length of it. So we printed out the file, we found out how big it was, and we printed it to the screen. Now, to be neat and complete with your programming, you should close the file when you're finished. So we use the file handle again. So file handle dot close. So here's another method, and then this just has empty parentheses. So let's fix my typo. So this will close the file. After you've done this, then you cannot, of course, do anything with the file again until you reopen it. But when you're finished, it's good programming practice to always do the close when you're finished using a file. All right, now this isn't going to change anything, but to prove that it works, then let's run the program. And I did not change the name of the file, so I need to fix that as well. So let's go back up here and fix that so that it really does have a file out there. And we'll do this one more time. Okay, so now come over here. Now everything's working, so we're back to this again. Now, what happens about, what if we want to do something with that extra character, you know, that end of line that's up over here? Maybe you want it, maybe you don't. So here's a way to get rid of it if you don't want it. After we read the data in, okay, so we read in the entire file, then we can remove that \n at the end of the file like this. Now I'm going to introduce a new variable. I'm just going to call it my_dna, and that's going to equal to my_file_contents. And I'm going to do a special thing here. I'm going to do something called rstrip. Okay, rstrip. So this removes a character on the right side of this string of information. Okay, so which one do I want to remove? Well, I want to remove this \n. So I'll put a quote and the backslash and an n, another quote, and close the parentheses. This will erase the \n. So if you want to get rid of it, you can. In fact, you can remove anything, any character that you want at the end of a string by using the rstrip. It only removes it from the rightmost side or the end. So you can remove an A, a T, an X, or whatever you want as long as it's at the end of the file. Now, we need to change this a little bit. We don't want to look at the My File Contents anymore, although I think I'll just leave that. Let's add some information here. So I'm going to print the My DNA file instead. So I'm just going to copy and paste these two lines. I'll copy, I'll paste, and instead of printing out My File Contents, I'll print out My DNA. Okay, so the My DNA variable is going to have the contents with the \n removed. So we'll print that out, and we'll get the length of it here, so we'll change that to My DNA. And then we'll print out how long it is. Okay, so that should give us the same output on the screen, but we will have removed the \n, so it should be one integer value shorter than what we had with the other file. Okay, so let's run the program, and let's see what we get this time. So let's pull the output over here, and you can see that's what we get. So the original file, we read it in like this. That was My File Contents with the \n. It was 19 characters long. Then I use the rstrip method, and it removes the \n, and now the length of that string is 18. So you can use rstrip if you need to remove the \n after you've read in data from a file. Before I terminate this video, I want to show you something else. As you can see, when we open up the file and when we read it with the read method, then it does read in the entire file. All right, well, it could be a very large file. What happens in that case? Let's take a look at a different file. This temps.txt file, if I open that up, then I can show you again, we have several lines of data, and each line just has one number on it. Let's open up that file and print it to the screen, and let's see what that looks like. So I'm just going to change the name of the file. We'll do our file open, so instead of doing the dna.txt, I'm going to do temps.txt. So that's going to open up that temperature data file, and everything else is good. I can still keep that. So now I am just going to run the program, and you'll look at what we have here. Right, so in the first case, we see that we print out all the data. So that comes, where does that come from? Okay, that comes from the the My File Contents. Then we strip off the \n, and then we print that out here. So the My File Contents, that's where we get this first list of data from the original one here. So we got all of that. And it actually counts how many characters we have. So it counted up 107. Then we print it out again, and didn't really have to do that. But when I copied it to My DNA, and we printed it out down here, that's where the second output comes from. So maybe I should have deleted one of those. But you can see what I'm trying to show you here. When you read in a file, you get the entire file, no matter how big it is. Everything comes into your program, and when you print it out, you can see we have output all of it. Okay, so that's a lot of data. Let's do one more. Okay, I'm going to close this down, and I am going to eliminate this second instance here. Okay, so let's take out the second print statement, and we'll just read in the My File Contents. We can ignore the strip for the time being, but then we're going to print everything out. We'll print My File Contents. Let's get an even bigger file. So if I look at another one, let's look at, what can I use here? I've got a dictionary. Let's open up this dictionary. So this is a huge file. Okay, this is a Scrabble dictionary, and you can see it has lots and lots and lots of data in it. What happens if I try to read that in? All right, well, let's just change it. Turns out it's called the Dictionary Four-Letter Words. So I need to type in this. I'm actually just going to copy and paste. So I'm going to copy that file name. And I'm going to change this up here. So now I'm going to open up ctemp dictionary four-letter words.txt. So that's going to open up that huge file. Then I'm going to use read. That will read in the entire file. Then we'll ignore the strip for the time being, and we'll print out the file contents. So this is going to print the whole dictionary out to the screen. And also it'll tell us how long it is. So let's see what happens now. Okay, so I'm going to compile or save and run the program. And what's happening here is Python is telling me that, look, there's a lot of stuff here. There's a lot of it. I mean, look at all those characters it counted, 20,149 characters. And it says it's got a squeezed text, double click to expand it. Okay, I'll double click and there it is. So this entire file, and I can tell you it's got over 4,000 words in here. But when you do a read in Python like this, then all of that information is input to your program and you can access it through whatever the name of the file is that you use. Okay, so my file contents in this case, that one variable has over 20,000 characters in it. So that's perfectly fine. If you want to do that with Python, then it will let you do it. That might actually come in handy if you're reading in a big data file that contains DNA bases, for example. All right, so that gives you the basics then of how to open up an existing file and read the data from it. So we will close this video at this point.